So the next part of abstract algebra is about open source frameworks. What's available? What can you use right off the shelf? And as I mentioned before, a lot of work has been done out of Twitter. There is an open source library for Scala. It's called Algebra. That provides abstract algebra definitions for different things written in Scala, such as scalding, and you can use it in Storm and Spark, etc. This is available at engineering.twitter.com under their open source. It's a project called Algebra. And it's interesting, when Twitter released this, it sparked a lot of discussions. It kind of took people by surprise because it's one of the early projects leveraging abstract algebra for popular big data frameworks. So people were asking, why would Twitter be interested in abstract algebra? Oscar Boynton, co-author of Scalding and Algebra and others as well, actually he answered this question directly on Stack Overflow. To quote, "The main answer is that by exploiting semigroup structure, we can build systems that parallelize correctly without knowing the underlying operation. The user is promising associativity." So let's break that down. Essentially, if you've got a monoid, then if you wrap your code as a monoid, again, making it a building block, but by virtue of having the abstract algebra, the monoids, you've got the connectors for the Lego blocks. If by using monoids we can take advantage of sparsity, we have to deal with a lot of sparse matrices where almost all values are 0 in some monoid. So that's what he's saying, is taking advantage of the identity element when they're going through a sparse matrix. By using rings, we can do matrix multiplication over things other than numbers, which on occasion we have done. So as I mentioned before, what if the sets that we're operating on aren't just numbers? What if they're trees? Or what if they're graphs? Or what if they're customer profiles? Or some kind of complex object that's represented in your programming language? You can still do these operations on them. So you can think of having a matrix of customer profiles and a matrix of log files and, I don't know, multiplying them together. That's essentially what he's talking about there. Boynton continues, the algebra project itself, as well as the issue history, pretty clearly explains what is going on here. We're building lots of algorithms for aggregating large data sets. Leveraging the structure of the operations gives us a win on the system side. It's usually a pain point when trying to productionize algorithms on thousands of nodes. So to break that down a bit, the idea is that at a place like Twitter, they're running on these clusters that have thousands of machines. Trying to build code that runs efficiently on thousands of machines is kind of a hard problem. But if you can have this layer, this abstraction layer, and then be able to apply your business logic wrapped up in your abstract algebra, then really you only have to solve the operations part of it once and then reuse it many, many times. There's a lot of great engineering reasons for doing that. Solve the system's problems once for any semigroup, monoid, group, ring, etc., and then you can plug in whatever algorithm you want without having to think about the implementation details of Memcache and Hadoop and Storm, etc. So really, Twitter used this on their ramp up to IPO to go from a point a couple years ago when they didn't have as many revenue apps to a point now when they have a very regular structure running these on efficient Hadoop clusters, Storm clusters, etc. Twitter released another project called Hummingbird, and it's got a great logo down there. It's got a Greek summation letter with a hummingbird. Very nice portmanteau. Anyway, they released it in 2013. It lets you write MapReduce programs that look a lot like native Scala collections. So what that means is in Scala, maybe you have a list of things. It might be a list of polynomials or a list of customer profiles or whatever. But you can basically apply functions to those data structures and then have a lot of MapReduce processing under the hood happen. And what he says is Twitter is doing this so that they can execute on Storm, Scalding, Spark, etc. In other words, to paraphrase from Twitter, being able to do monoids in real time. So the idea is that via Hummingbird project, you can take and define your business logic reusing all those nice components of your Lego blocks, fit them together, and come up, sorry, here I am. Let's make something interesting with Lego blocks. You can come up with a complex workflow that, I don't know, maybe it looks something like this. So you've got a complex workflow, but you're not really concerned as much if it's going to run on Hadoop or if it's going to run on Storm or Spark or something else under the hood. You just have your framework be a parameter. And this is really effective for a team context where you're defining, say, a big batch job to calculate, I don't know, week-over-week customer metrics. And you want to be able to do that every quarter, let's say. You start out doing that. And then you realize, I want to take and run that same code every day. So you've moved up your batch schedule. And then you start to realize, I really want that every 15 minutes or every 5 minutes or every minute. And now you're starting to get into some kind of more low latency, real-time application. Hadoop will probably take you along the way of doing it every quarter or every day. But when you get into every 5 minutes, Hadoop's not going to work very well. Something like Storm or Spark Streaming, other types of frameworks are much more amenable to doing low latency kinds of applications. What Twitter has done is to be able to build a way of using Hummingbird, define your logic up at a high level, your business logic, and then add in a parameter. Do I want to run this in batch on Hadoop, or do I want to run this in real time on Spark Streaming? That's a very powerful thing. Now, it's not just limited to what we're doing in Scala or Clojure or other types of languages like that, which are typically going to be running on Linux. Twitter and others use a lot of Linux. There's also a really great project called Embrace. It's written in F# and it runs on .NET for Windows. I highly recommend checking it out. In some ways, I think that the Embrace project is maybe even a little bit more advanced than what Twitter's done with Hummingbird, although arguably I think Hummingbird runs at very, very large scale. It's very proven. The thing about Embrace is that it's very flexible. In about 20 lines of code, you can define what is essentially MapReduce. So here, we've got an F# program that establishes what a MapReduce framework is going to do, how that computation is going to work. And again, they're defining this stuff in terms of monoids. But the nice thing about Embrace is that you could go in and do something other than MapReduce. MapReduce has some limitations. It's a kind of, I would call it a barrier pattern, but there are other things that you might want to do with parallel processing other than MapReduce. So Embrace allows you to essentially reconfigure your cluster and provide a lot more interesting kinds of abstractions. And I have a hunch that these kinds of best-of-breed features are going to cross-pollinate. We'll probably see things like that showing up in something more on the Scala and Linux side as well. As a sidebar, I definitely like to point out about Jimmy Lin. There's a paper that he did, a very good one called Monoidify. Actually, from what I understand, he was working with Oscar Boynken on this one. But you may have noticed that there's several names I've mentioned from Twitter. Avi Bryant used to work there. Sam Ritchie used to work there. Oscar Boynken works there now. Jimmy Lin is another person who's been a real driving force of nature at Twitter. He's a professor at University of Maryland, but he's also doing a lot of work on Twitter open source. And it's remarkable. He seems to publish papers in just a stream of academic papers that get accepted in peer-reviewed journals. This one in particular, Monoidify, I think really brings out quite succinctly why is it that we're using abstract algebra for these really large-scale systems in open source. And like I say, he's been a real driving force behind how Twitter has built out their revenue apps. Highly recommended.